Example 24 has given us two pieces of information. And the first one is that the sum of the first three terms of an infinite geometric sequence is 43. So that means S3 equals 43. And the sum of the series is 43.2. Notice that no endpoint is listed, it's just the sum of the series. And so that means that the sum to infinity is 43.2. So what these two pieces of information tell us is that we need to use the sum to n formula, which is T1 outside of 1 minus r to the n on 1 minus r, and the sum of the series, or the limiting sum formula, which is T1 on 1 minus r. The reason that we use these is because, firstly, that's what those numbers 43 and 43.2 represent. And secondly, we've now got this expressed in terms of T1, R, and N, which we know. So the sum to 3 tells us that 43 equals T1, we'll just call that A outside of 1 minus our common ratio to the power of N, which in this case is 3. Divided by 1 minus our common ratio. The sum to infinity tells us that 43.2 equals A, our first term, divided by 1 minus R. And you should see that we've got A divided by 1 minus R on the right-hand side and A divided by 1 minus R over here as well. So we're going to rearrange the left-hand equation by dividing down by 1 minus R cubed, and then we'll have A on 1 minus r as the subject. So it's going to be, oops, wrong pen. It's going to be 43 on 1 minus r cubed equals a on 1 minus r. So now these two things are equal to each other. So therefore, 43 on 1 minus r cubed equals 43.2. From here, we rearrange, so we multiply up by 1 minus r cubed. And divide down by 43.2. From there, I'll come over here. Haven't left myself much room today. If you do 43 divided by 43.2 on the calculator, it actually comes out as 215 216ths equals 1 minus r cubed. Then we take one from both sides. So 215 minus 216, divided by 216 minus 1 equals minus r cubed. Now 1 is 216 216th, so 215 minus 216 is minus 1 216ths equals minus r cubed. We cancel the factors of minus 1 and we're left with 1 on 216 equals r cubed. Then we take the cubed root of 1 on 216, and you can do that algebraically or via your calculator, and you'll end up with r equals 1 on 6. So that's the first part of the question that we're being asked. The second one is what's a? So when r equals 1 on 6, I'm going to sub it back into this equation here. 43.2 equals a on 1 minus 1/6. So then it becomes 43, once you simplify that, a on 5/6. So we go 43.2 times 5/6 equals a. Therefore, a equals 36. And so in conclusion, squishing it all in here, therefore, a equals 36 and r equals 1/6. And that's it. With the next example, 25, I'm going to leave you to have a fiddle around with that one. It's a very, very classic question of this type of geometric sequences. Zeno was one of the Greek philosophers, so he was around sort of 400 or so BC, I believe. Have a little think about this problem. See if you can think out a solution and then have a go at actually writing out a mathematical solution. Okay, and that's it.